In a moment we'll be looking at our model HFBV-9810. This is our latest version of our bellows hydroforming machine. This unit is a low production unit, and you can form with one set of dies approximately 20-25 bellows a day. It is ideal for a very low production shop, very simple to operate. This unit has two reservoirs. One reservoir to supply the tube, for pressurizing the tube when we form it, and the other reservoirs to operate the hydraulic cylinders. The unit is plumbed with sufficient valves and relief valves and solenoid valves and pressure reducing valves and flow control valves. There's two motors on this unit, one for each reservoir. A good filtering system to refilter the oil back into the system after it's used to form the bellow. We're looking at a pressure compensated pump. This unit will go up to 5,000 psi. On the other side here we have a little gear pump which drives the hydraulic forming part of it. There's 3 hydraulic cylinders to this unit. 2 small cylinders to operate the seals, and 1 larger cylinder to do the compression. We're looking at one of the seal cylinders right there, and we're looking at the seal right there on top. And on the bottom here we have another one. We can get a good view of it. We're looking at a stack of dies inside the machine at the moment. In a bit we'll be forming some bellows so you can get an idea how it works. There's sufficient oil reservoirs in terms of the amount of oil so that there'll never be no overheating. This unit can be is good for making or operating for 2 shifts without any problem. We're looking at an assembled set of tooling, and each tooling is specific to its own design. There's the upper seal, upper cylinder, seal cylinder. There's 3 proximity switches. There's the middle one, and up above is a home. Some of this might be a little blurry. Looking at the control unit, the upper left hand switch is a compression cylinder. It will manually work up or down. On the right hand switch it's a tube pressure, and on the lower left hand switch it's the seal switch for the upper and lower seals. 3 relief valves in the system. What we're looking at right now is a relief valve for the tube. This is the valve where you set the pressure that you need to form the bellow. There's the gauge to read the pressure. There's a little switch right there, and the operator can do it right there, hands on, without any problem, right in front of him. There's 2 starter boxes and a transformer. The transformer is to reduce 230 down to 110 volts for the solenoid valves. The starter box on the left is to operate the hydraulic press. The starter box to the right is to operate the tube pressure system. Notice here, that's the oil gauge on the reservoir. This oil is red. It's because it's water-soluble oil. And you can just wash the parts out with water and blow with an air hose and you're okay. And here is the return tank. After you form a bellows, when you lift the tooling off the seal, some oil will come out that's left in the tube, and it'll drain on this hose here, come right down and drain right back into tank. We're also filtering this oil so that we keep the oil as clean as possible going back into tank. There are sufficient safety shields around this unit, and whenever an operator is forming, the front seal or the front safety shield should always be closed. There's no danger of any explosions or getting hurt in any way because we don't go that high of pressures. The worst case scenario would be that somebody's going to get a lot of oil, but they can wash it just with water because of water-soluble oil. That's the one with the high pressure. But it's a good idea to close the shield prior to any forming, especially during testing parameters, because if you'll notice on all of this tooling, there are mechanical or shims or spacers that we use. These spacers are used to set the pitch prior to forming. These parameters have to be developed. The amount of spacing and the amount of pressure is very critical to getting the bellows to the drawing specifications. Because this machine does form just low production bellows, and depending on the wall thickness that you're using, each one of these plates are tack weld at the very ends, as you can see right there. We'll go through a little exercise in assembling this tooling a little later on. There's 4 guide shafts that you see there, and then when the forming head comes down, you'll see 4 holes on the upper plate and also on the lower plate. These shafts will enter into those holes so that when it's collapsing, the shafts will be able to go somewhere without damaging the compression head. As I say, this is a low production machine. AMH makes high production machines where you can form a bellows in 15-20 seconds, or even as fast as 8 or 10 seconds. This is an economical machine and is an ideal for companies that just wish to produce bellows to support their own product line. I'm going to tack weld and just a little bridge across the tooling. If I can get in here and zoom in here so you can see it. The amount of rings that have to be tacked will vary depending on the pressure used to form the tube. This particular tube has 12 convolutions. It's 20 thousandths thick and has to be formed at about 2,000 psi. So in order to keep the dies from separating and leave excessive die marks in between the dies, we have to tack weld every other die ring. Of course, those 4 shafts will also help it to keep itself closed during forming. Also, the top clamp and the bottom clamp are bolted together. Just using an impact wrench, you can take that apart real quick and doesn't take much time at all. And we're going to get ready for a form cycle. We'll try to go through this as slow as possible so you can understand what the process is. Now, in the control panel, there's some safety features to ensure that the operator doesn't put the oil on without the seals being inside the tube or the seals being activated. So there's 3 proximity switches, and the very top one is home. The middle one is where you establish the starting point for the bellows assemblies as they're set up. You see them, and the last one is for the final stroke with the bellows all collapsed. We're going to go start forming. Now we have the tooling in place, and we're going to go ahead and okay. Now we've got a part in the machine. Now we're going to get ready to form. So go ahead and start forming, Ralph. Start the operation. We're going to bring the upper seal down and into the tube. and it's going to make the center proximity switch and stop. Now he's going to activate his seals. Now the seals are on. Now he'll pressurize the tube. Now the tube is being pressured. Now we'll look up here. He's reading 2,000 psi up there. And he's making adjustments up there wherever he wants. Okay, Ralph, turn it off now. Now he turns off the oil, and now we're going to remove the spacers. What he's doing with just a little hammer, he's just tapping the spacers out. Because once the pre-bulge takes place, we just tap the spacers, will come right out. And when he gets them all out, then we'll be ready to form. But before you start loosening these or taking these spacers out, it is recommended to raise the top seal up just enough to take the pressure off the dies. We've removed all the spacers, and you'll get a good look and a good view there. Hard to say with the background, but you got to check and make sure that there's no spacers in there, because if any spacers are left in there during the form process, you could destroy the dies. So now the spacers are all out. I'm going to bring the seal back into the bellows until he makes a proximity switch. Now he'll put the seals on again. Now he'll pressurize. Now he'll collapse it. Now the bellows are being formed. So he makes a lower proximity switch, which is right there. Turn off the pressure. The bellows is formed. Okay, now that it's collapsed, he'll go and he'll turn off the seals. The ram will not retract without the seals being off. Now he'll retract the ram.
Up, right?
And he'll go all the way up to the home position. And you'll see there where the rods have gone into the upper die assembly, or the upper seal assembly. Now we're going to remove the part. He's going to remove it. You'll notice that he has to cock it a little bit because that oil down on the base, and you can see the oil is going to drain down on the base. That oil down on the base will form a vacuum. Now he's going to bring it over to the bench. And now what he's going to do, he's going to proceed to cut the tack wells. Okay, now he's cutting the tack wells. And this will only take just a few minutes. Remove these 4 bolts on the end clamps. If you have a little impact wrench, it'll make it a lot faster for you. There's a lot of things you can do to speed the process up once you start using the equipment. Okay, now after the bolts come off, now we're just going to separate the dies. You can see here where the ballast has been formed. Try to get a good shot of it here. I don't know how blurry it is, but you can see where they form in. Here's the opposite side of the die, and here's the ballast that's formed in the tube. Now we'll remove the tube out of the die, and there you go. You can see it. Okay, now after we've washed the part off and everything, you can see the I'll try to get a better shot of it here. And you can see that the end convolution here, this is going to be trimmed right there on both ends, and this convolution here doesn't go all the way down to the bottom pitch. We're looking at here, you get an idea as to what the starting length of the tube is and what the length of the bellows is after it's formed. A shot of the machine here, we're looking at the filter that we use to drain the oil as it goes back into the tank. after so many hours or so many cycles of forming, it's a good idea to check the filter and just remove the threaded portion on the bottom there, and the screen will come right out, blow it out, wash it up, and it's ready to reassemble. We're looking at a unit right now that we're preparing right now to ship. They all are boxed on solid pallets. And they're enclosed completely. We do this so that we can be sure that the machines will be well protected. Again, this is another product designed and built by AMH to meet customers' specific needs. Thank you.